George is the science boy.
George Boyd, the science guy.
George
Boyd, the science guy.
Science rules.
George Boyd, the science guy.
Inertia is a property of matter.
George Boyd, the science guy.
Boyd is the science boy.
Boyd. Hi everybody, welcome back. Today what we're going to do is we're going to start talking about moisture and humidity in the atmosphere. And the first area of discussion is going to be, how does water get into the atmosphere? And there's two different ways. The first way is evaporation, which requires energy, mainly from the sun, and transpiration, which is the method by which plants absorb moisture through their roots and release through their leaves. When we're talking about the atmosphere, we're referring to the troposphere, which is the bottom layer. It's the only layer that has water. As a result, it's the only layer that has weather, and that's where we live. Okay. Evaporation happens more so in areas that are warm. Those are areas of low latitude near the equator, in the tropics, where there's more evaporation. And if you've ever gone on vacation down in the Caribbean, you know when you get out of the water, you have a thin layer of salt on you, more so than around here in Northport. The reason for that is because the water's saltier, it's more concentrated. The more evaporation you have, the more concentrated the minerals are in the water. So evaporation happens mostly in the summer. The largest source is the part of the hydrosphere that's obviously got the most surface area and the most volume. So that's going to be the oceans. So the ocean's right here. Okay. Transpiration, that's the second method. What happens is plants soak up water through their roots and give them off. We perspire, plants transpire. So plants give off moisture through their leaves. Now, these two methods, evaporation and transpiration, can be either sped up or slowed down by these four variables right here. The first thing is energy available. If it's hot out, obviously water evaporates quicker because you need kinetic energy to go from a solid to a liquid to a gas. So when you have liquid water and it absorbs energy, in particular from the sun, what it'll do is the molecules will speed up, break bonds, spread out, and enter the gas phase. So the energy available is the first thing that we address. The second one is surface area exposed. If you have a glass of water and a plate of water, what you need is an exchange of energy from the atmosphere to the liquid. So in order to efficiently transfer that energy, you need a big surface. This right here will evaporate quicker than a glass because the only area where evaporation is occurring is up here at the top. Here it's happening all along the surface. Another variable is wind speed. When you want to dry your hair, okay, how do you increase that? The rate at which it dries, what you do is you blow air on it. What you're doing is you're increasing the volume of air coming in contact, transferring the energy, and as a result, allowing it to evaporate. If it increase it even more, you can increase the energy available by turning on the heat. So then what happens, if you got long hair, what you do is you turn the heat on, you turn the air all the way up, you're increasing the volume of air, and you also increase the energy available. Okay? Okay. The other thing is humidity. If you have water on a table and you want to pick it up, what's the easiest way to absorb it? With a dry sponge or a wet sponge? Obviously a dry sponge. If you think of the atmosphere like a sponge, when it's full of water, when it's close to saturation, it can't pick up water. It can't absorb it. So if it's really humid out, like in the summer when it's hot and sticky, A lot of times people say, "Oh, I wish it would rain so that it would be more comfortable." The reason is because your body gives off water, okay, through its pores, and that water, when it evaporates off your body, draws heat, so it cools you. In the summer, if it's humid out and the air is somewhat saturated, that water that's on your skin can't enter the air, so it just stays on your skin. That's why you're hot and sticky. So humidity, as humidity increases, evaporation decreases. The more humid the air is, the more full it already is, the slower it's going to evaporate. Okay? So when you hang clothes out, obviously when it's hot out, you have more energy. It's going to evaporate, dry quicker. Also, if the air is dry, it's going to dry. If the air is dry and humidity is low, it's going to evaporate quicker. Interesting fact, warm air holds more moisture than cold air. So if you notice in the winter when it's cold out, the air is actually very dry. That's when you have to use chapstick to keep your lips from chapping, and also your skin dries out. Okay? So those are the 4 factors that affect evaporation rate. How does water enter the air? It evaporates and it transpirates, which comes out of the leaves of plants. What are the 4 things that affect those rates? Energy available, surface area, wind speed, and humidity. Okay? All right, if you have any questions, just email me. Thanks a lot, and have a good day.
George, here's the science boy.
George Boyd, the science guy.
George.
George Boyd, the science guy.
Science rules.
George Boyd, the science guy.
Inertia is a property of matter.
George.